growth of data has forced us to examine the existing approaches to data management, resulting in a new paradigm to data processing. By the year 2020, the internet is expected to reach 1.5 gigabyte of traffic per day per person. However, the Internet of Things, driven by objects, will far supersede these data rates. For example, a connected aeroplane will generate around 5 terabytes of data per day. This amount of data is impossible to analyze in a timely fashion when sent to one central location. You simply can't send everything to the cloud. Even if you have infinite bandwidth, which you don't, latency will always get you. For example, in virtual reality, anything over 7 milliseconds will cause motion sickness. Too much latency within the self-driving car environment can cause more serious problems. When you need real-time decisions, you cannot send data to the cloud and wait for a response. Also, IoT devices are highly distributed, making them harder to connect to a centralized cloud. These challenges result in new end-to-end architectures and the introduction of a decentralized edge layer. Decentralized architectures are nothing new and were initially seen in the X25 pad days. Edge computing moves certain types of actions as close as possible to the source of the information. It is the point where the physical world interacts with the digital world. The decentralization approach to edge computing is not trying to take over from the centralized approach of cloud computing. The two will be used together. The benefits of both architectures will be used in conjunction, allowing applications to run best depending on where they're positioned in the network. For example, a lightweight IoT device does not need to keep sending keep-alive traffic over bandwidth-constrained links to the cloud. In edge computing, applications are still connected to the internet and have access to cloud services, but they have additional onboard computing power so they can operate by themselves or, depending by design, send information to a fog node or other gateway device. Fog is the midpoint between an IoT device and the cloud. It may still have the same compute, storage and network capabilities of the centralized cloud, but it's moved closer to the edge. A cloud that is really low to the edge is called mist. Mist computing is between directly connected edge devices, whereas fog communication is the IoT network. The Open Fog Reference Architecture published architectural guidance and recommends a hierarchy of fog nodes, allowing redundant communication to a group of sensors. They reduce the quantity of data as much as possible before it gets sent to the centralized cloud. A fog node is contextually aware and only sends back relevant data to the cloud, keeping latency to the minimum.